Hello, and welcome to this exam marking video on transpiration in plants. As long as you've got your green pen, blue pen at the ready, we will get started. Okay, question 1a. I've got a cereal crop, complete spaces I and II. So look at our diagram first of all. Here's our cereal crop. What's happening now? I've put some extra blue arrows on here just to help you visualise this. So we've got one arrow coming up there and the other arrow going in here. I and II, the gaps we need to fill are both processes. There's the process of something in the leaves. I hope you bugged that it happens in the leaves because that's useful information. And there's another process, the process of something in the cells. What other information have we got here other than that I happens in the leaves and II happens in the cells? Well, the one that happens in the leaves is what's happening here. It's taking in carbon dioxide and it happens in the leaves. So write that down. We need a process that takes in carbon dioxide and happens in the leaves of plants. And II, we need a process that happens in the cells of plants, and what's it doing? It's releasing. Carbon dioxide is going out and into the atmosphere. So we need a process that happens in cells, every cell, moreover, that releases carbon dioxide. What are these two answers? Well, the process that happens in the leaves of plants takes in carbon dioxide. I hope you've got it. It is photosynthesis. If you don't know your equations photosynthesis and respiration yet, you must learn them. Okay, photosynthesis takes in carbon dioxide, combines it with what now? Water. Okay, produces glucose, C6H12O6, and what's the last thing? Oxygen. Lovely. Okay, so then we need another process happens in every living cell, to be precise, releases carbon dioxide into the atmosphere. I hope you're shouting it at your computer screens. It's respiration. Releases carbon dioxide. In case you don't know respiration, I'm going to tell you. 6O2, by the way, there should be a 6 down there. 6O2 plus, what is it? Glucose, C6H12O6. That's why we need to eat, so we can respire. Produces, by the way, notice, it's the, I've swapped, look, the reactants and the products of photosynthesis. They're just the reverse of the reactants and the products of respiration. So now it produces the carbon dioxide, and that's what goes into the atmosphere. It also releases water, 6H2O. Yeah. Right, what sort of weather may cause the cereal crop to wilt? Now, in case you don't know the word wilt, wilt means it becomes floppy. Or another word for floppy, which is good to know, is flaccid. Hopefully that's sort of rung a few bells for you. Where have you come across the word flaccid before? Probably with guard cells. We've talked about guard cells going from being turgid, where they're stiff and solid, to being flaccid, where they're floppy. Now when a plant becomes wilts or becomes flaccid, the plant starts to kind of flop over. Do you remember what causes a guard cell to go from being turgid, where it's stiff and holds its shape, to being flaccid, where it's floppy, and in the case of the guard cell will cause the stomata to close? Well, if you don't remember, I'm going to tell you. It's turgid when it's got lots of water. The water pushes against the cell wall, holds it open, and it becomes flaccid when it has a lack of water, and the lack of water means that the cell wall starts to flop inwards and the whole cell becomes flaccid. Now, you can't just write, though, lack of water, and the reason is the question is very specifically asked for a sort of weather, and you wouldn't turn on the weather forecast and they say, the weather forecast today is lack of water. So you need to give me a type of weather. Dry would be fine, okay, that's the type of weather. We're having a dry day today. Hot, a hot day would also mean that there'd be a lack of water, because the water, transpiration would increase by lots of other reasons, but dry or hot, the two obvious answers. Windy as well would increase the rate of transpiration and be a correct answer, though dry I think is the most obvious. Moving on now, seemingly easy question, but actually I wonder how many of you will have got your 3 marks on this. Describe the process of transpiration in plants. If you see the word describe, you need to write an awful lot of detail. That word means they want more detail than you are probably expecting. Another hint is, look, it's 3 marks. Now that could be 3 easy marks, but you need to put a lot of detail to get those 3 marks. So let's start off with what we know. Transpiration, I hope the bit that everyone knows is the diffusion and evaporation In fact, evaporation being the more important term here, diffusion wouldn't actually get you a mark, but the evaporation of water would. Yeah. Where does it go? Come on, as much detail as you can. Through the which part of the leaf? The hole in the bottom of the leaf, but you don't get a mark for saying that. You need to give it its name. Through the stomata. Say it's in the leaf. Okay, anything like this where you can show off what you know, put it down. Detail. The evaporation of water through the stomata of the leaf. By the way, so you get a mark for leaf, you get a mark for stomata, so that will get you 3 marks. But detail, detail, detail. Never ever be overconfident and think I've got enough information. What else do we know about transpiration? Well, that it pulls up, right? Water evaporates through the stomata, causing a pool of water. And where does that water come from? Okay, it comes through, enters through the, which part of the plant does the water enter? The roots, or the root hair cells, via osmosis, you could even put, and then moves up the plant. And that's not actually transpiration, but that's the transpiration. Can we get this last mark? Moves up the plant through the transpiration. Do you know what word I'm waiting for? Stream. Okay, that's on the mark scheme, right? Putting as much information as you can here gets you marks. So I mean, let's look at what we've got here. That would get you a mark. Stomata would get you a mark. Leaf would get you a mark. A pool of water would get you a mark. Water moves up the plant through the transpiration stream, enters through the roots. Okay, there's 1, 2, 3, 4, 5, 6, 7 things that you could have put down. I hope you put as much detail as you needed. Right, the image below shows some cells on the lower surface of a leaf. Lovely. Let's have a look at the image. We've got a little hole here which has been labelled as the stomata. Really useful. Lots of people get confused. The stomata is the hole in the leaf. It's not the cell. Okay? Stomata is the hole in the leaf. And then this X is pointing to the cells either side of the hole. Okay, I'll show you with my hands. There's the hole in the leaf. Okay, down here. And then these are the cells either side that open and close the stomata. What are the cells labelled X called? Hopefully you know this one. They're guard cells. Just wait for that. In case you are confused or you did circle palisadal mesophyll cells, quick little diagram of a plant here. We've got the waxy cuticle on the top. We've got this layer here. It's a transparent layer called the epidermis. Can't spell. Epidermis, or the epidermal cells. Here's the palisade mesophyll layer. The site of what process? Photosynthesis. Good. Spongy mesophils down there. Air spaces to allow for the evaporation and diffusion of gases, water vapour. Here we have the lower epidermis. The holes in the bottom are called stomata. I hope you're thinking that's obvious. And then the cells either side of the stomata, those ones there are the guard cells. Okay, opening and closing the stomata. Just in case you were confused on that one. Right, over we go. Experiment time. Water lost by evaporation from leaves is called transpiration. The student set up an experiment. When you get a question on an experiment, you see, oh, it's an experiment. Get this down, chimed. What does it stand for? We change the independent. We measure the dependent, and then be thinking as you read through this and as you bug through this, you're going to try and get as much of this down as possible. See if you can notice the independent, see if you can notice the dependent. They investigated water loss from leaves. They took 2 leaves from a plant. Why have I underlined this loads of times? Because there is information here for you, and if you read carefully you notice it. From a plant, they took 2 leaves from one plant. So that is something they've kept the same. They used the same plant. What kind of variable is that? Control variable. Okay, you can notice these things if you just bug carefully. They put Vaseline on both sides of leaf B, did nothing to leaf A. Which variable is that? Control, independent, dependent. What have they done? They have changed it. Okay, on leaf B they put Vaseline, on leaf A they did nothing. So which variable is that? The one that we change. The independent variable. Lovely. Wrote down the mass of each leaf. Obviously they've had to measure the mass of each leaf, haven't they? So I know what I'm thinking. Attach the leaves onto a string, fine, there they are, left the leaf for 48 hours. Why have they told me that? That is useful information. Is it something they've measured? Is it something they've changed? No, it is something they have controlled, right? They have kept it the same, both leaves for the same amount of time. It's a control variable. Wrote down the mass of each leaf again. Hang on, how did they find out the mass? Must have measured it. Calculated the percentage change in mass for each leaf. The only variable we haven't yet talked about is the dependent. Hopefully you're sort of, thinking theorem is clear. Obviously, the dependent variable here is the percentage change in mass. That's clearly what they measured. Right, now look, if you bug carefully like that as you go down, questions become a lot easier. Give one variable the student controlled. I've already found two for you. Okay? They used the same plant and they left it for the same amount of time. Those are the only two that would get you the mark, because they are the two that are made explicit in the question. The mass of leaf A was 1.60 grams at the start of the investigation. After 48 hours it was 1.28 grams. Calculate, so calculators are ready. The percentage decrease in mass. Now, tricky this. Don't think that this is easy. Let's have a little think about how we're going to do this. First of all, let's imagine they just said calculate the decrease in mass. If it started off as 1.6 and it ended up at 1.28, let's just work out the decrease. Okay, that's the first thing I'm going to do. So I'm just going to think, let's not overcomplicate it. 1, find the decrease. And then step 2, we're going to turn it into a percentage. Okay, first of all, what was the decrease? Well, it started off as 1.60 and it ended up at 1.28. So how much did it decrease by? 1.6. Let's take away 1.28. So the decrease in mass was 0.32 grams. That was the normal decrease in mass, but they've asked for a percentage decrease in mass. So I need that as a percentage of the mass. Okay, this was the mass at the start, so I need 0.32 as a percentage of 1.60. How do we find percentages? We put the part over the whole, over the total. 0.32 divided by 1.60, turn it into a percentage. One final step you need to remember. 4 multiplied by 100. 0.32, I'm going to divide by 1.60 and I'm going to multiply by 100 to get a percentage, 20%. Okay, hopefully you got that. Well done those who did. Not the easiest of questions, that. Right then, where are we? We've got Vaseline blocks the stomata. Percentage change in mass of leaf B was less than leaf A after 48 hours. Explain why. Let's go back and think about what this means. Vaseline, so which leaf did they put Vaseline on? Can you remember? Should we go back and check? Put Vaseline on both sides of leaf B. Vaseline blocks the stomata, so which leaf had blocked stomata? Leaf B had blocked stomata, whereas leaf A didn't have Vaseline, so leaf A didn't have blocked stomata. This is what they've changed. They've blocked the stomata of leaf B and they haven't blocked the stomata of leaf A. Percentage change of mass of leaf B was less, so it lost less mass than leaf A. Leaf A lost more mass. Now, we need to explain what this has to do with this. The leaf that lost less mass had blocked stomata. The leaf that lost more mass had open stomata. What does open stomata have to do with losing mass? What substance is it losing? Leaf A, the one with the open stomata, lost what substance? Through what process? We know they lost more of something, and it has something to do with the stomata. They lost more water through what process? The diffusion of water through the stomata. What's that process called? Transpiration. Okay, now you would get the mark if you just said water loss or more transpiration or less transpiration. By the way, you'd also get it if you did the flip side. So if you said leaf B lost less, that would get you marks as well. If 3 environmental conditions increase transpiration, But so what you can't just do is say temperature. Okay, you need to tell me whether a higher temperature would increase transpiration or a lower temperature. Okay, so be specific here. Do we want hotter or colder? I've given you a hint on that one. Hotter. A higher temperature would increase transpiration. The particles have more kinetic energy. They evaporate more. They diffuse faster because they've got more energy. Windier. That's because of the concentration gradient, and it's on a windy day. The wind blows away the water vapour from outside the leaf, makes a steeper concentration gradient. And then the one that catches people out, humidity. Do we want more or less humid to increase transpiration? We want it to be lower humidity, less humid. What that does is increase the concentration gradient again. Lower humidity means there's less water. This wouldn't get you marked, I'm just writing this blue pen. Less water vapour in the air. If there's less water vapour in the air, there's a steeper concentration gradient. Okay, because inside the leaf there's lots of water vapour, and outside the leaf there's not much on a not very humid day. Okay, that's a steeper concentration gradient on a not very humid day. By the way, if you just said dry, you would also get the mark. The reason, no, let's leave it. Right, moving on. Another experiment. We've got a experiment set up measuring the rate of water. You know what I told you to do. Figure out what these variables are. We're going to, as we read, we're going to bog it. We're going to write down what they're changing, what they're measuring, and what they're controlling. Setting up this thing, we've got plant cutting there. We've got an air bubble. This is a potometer, for those who keen beans amongst you. They set them up in 3 different conditions. They are changing it. So what variable is it? The independent variables are as follows. We've got wind, or no wind, that's one independent variable, and then we've got a change in temperature. So we've got 2 independent variables here, whether there's wind or not, and what the temperature is like. For each experiment, the students recorded the movement of the air bubble. What variable is that? They're measuring it. It's the dependent. Okay, of the air bubble on the scale. Now just to check you understand, if the air bubble moves a long way, what does that mean has happened? Okay, if the air bubble has moved a long way, the rate of transpiration is high. The reason is because the only reason the air bubble moves is when the water goes up and out of the plant. Okay, that's what causes the air bubble to move, is the water going up and out of the leaves. That's transpiration. So the further the air bubble moves, the faster the rate of transpiration. Make sure you've understood that. Moving a long way means a fast rate of transpiration. Then 2 variables the students chose to change are. That's helpful, almost clear. We've already figured out what the independent variables are. Easy peasy lemon squeezy. Wind and temperature. Okay, as I say, always bog carefully. It was important to use the same plant cutting, that's a control variable, each time to make these experiments fair. A fair test is one where only the independent variables, the ones they're changing, will affect the dependent variable. That's a really useful bit of information for you to explain why. Why is it important they use the same plant? They want to make sure that only wind and temperature are affecting the rate of transpiration. If they used a different plant, it would affect the rate of transpiration. We need to explain why. Why will a different plant affect the rate of transpiration? Loads of reasons. Different plants have different sizes. They have different number of leaves. More leaves, more transpiration. They have different surface areas. They have different numbers of stomatas. You need to have explained why using a different plant would have affected the rate of transpiration. What else could you have said? Different plants take up different amounts of water. Different plants need different amounts of water. Some explanation as to why different plants would affect the rate of transpiration. There we go. Graph shows the student results. Now, could you remember what I said before? So line A has moved the furthest. Okay, line A has moved 68 millimetres. The one that's moved the furthest, has that got the fastest or the slowest rate of transpiration? It's the fastest. Like you were listening earlier. The one that's moved the least distance has the slowest rate of transpiration. Okay? Which line shows the results for each of the different experiments? So we need to work out, we need to put these in order, right? Which one's going to be fastest? Okay, let's start with the first variable, wind or no wind. Which one's faster? Is transpiration faster when there's wind? Is transpiration faster when there's no wind? It's faster than there's wind. So we think that this one's going to be fast. I'm going to put 1F for fast. And then let's look at our second variable. Is it faster when it's colder, or is it faster when it's hotter? Faster when it's hotter. Okay, so we think that the two at 25 degrees are going to be the fastest. Notice, wind at 25 degrees is going to be the kind of fastest for two reasons. So that's going to be line A. No wind at 25 degrees is going to be faster than no wind at 15. Slightly fast, so that's B. And no wind at 15 is going to be the slowest. So that one's C. Okay, moving on. Another experiment for you. Set up the following apparatus. What should we be noticing? Of course, these. What are they changing? What are they measuring, etc., etc. A balance measures what? Obviously that's going to be the dependent variable. A balance measures mass. That's what balance is measured. So that one's going to be the dependent. What have they changed? Well, this one's got a plant in it. This one hasn't. Pretty obvious. And then they're investigating how that affects mass. The balances show the same mass. They started off with the same. After 24 hours, by the way, they kept the time the same. So that's a control variable. Mass of flask B was the same. That hadn't changed. Mass of flask A had changed. Describe, give me detail, and explain, tell me why the change to the mass of flask A. So what will have happened to the mass of flask A? Why will the mass have changed? We've got water and we've got a plant. What happens to the water? It goes in through the roots, it goes up via the transpiration stream, and then it goes out through which part of the leaf? Stomata. What's that process called? Transpiration. Right. I want 3 marks worth of description, detailed description, and explanation, explaining why that mass is going to change. First of all, describe. The mass is going to decrease. That's the description of what's going to happen. The mass will decrease. Now why? Because the water has moved up through the plant. Water into plant, evaporated through the stomata, out of the leaf, more detail the better, out of the leaf, through the stomata, anything else that we could have said? Yeah, okay, it didn't soak into the plant, it moved up through the plant and evaporated out of the leaf through the stomata, therefore the mass decreased. Okay, something along those lines. Why did the student need to set up flask B? Whenever you've got something like this, where you haven't changed anything, it's called a control. Okay, it's called a control, so that will get you the mark. Act as a control. If you wanted to explain what the control is doing, it is to check the effect of the plant. It's proving that mass wouldn't be lost anyway. Okay, what is meant by the transpiration stream? Slightly different question from before, because here we've got the stream. Okay, it's not just transpiration, so I need to go into more detail. Just a quick check. How many marks? How much detail do I need to give? 3 marks. An awful lot of detail. Okie dokie. What's the substance that moves in the transpiration stream? Water. Okay, where does it move? Through a plant. In fact, even better than that, up, because it doesn't go down. Up a plant. Where does it enter? Enters the plant through the which bit? Roots. Via process, osmosis. What vessel does it travel through? Moves up through the xylem vessel. things to add to the leaves. What happens when it gets through the leaves, where it evaporates and diffuses out of the stomata. Okay, loads of detail that you could have given. Did you give as much detail as I have given? I hope you did. We are on, I think, now the final question, so here we go. Keep the focus, keep with me. Graph shows rate of transpiration at different times of the day. Quick little look, we've got starting off at the morning, this is the rate of transpiration, so as we go up it's getting faster, and as we go down the rate of transpiration is getting slower, and as we move along the x-axis we're getting later in the day. Transpiration occurs mainly in the leaves of a plant, through which part of a leaf. Now the reason I've underlined that is because I bet you that some of you have written a leaf. It says which part of the leaf, so don't just write leaf. Does most transpiration occur? Transpiration, diffusion of water. Through which part does the water diffuse? Through the stomata. If you said stoma, that's fine. In this investigation, rate of transpiration decreases between 1600 hours and 1900 hours. When you get things like this, mark them on. Find 1600 hours. There it is. Draw a big line, right? Make it really obvious which bit of the graph it's talking about. And 1900 hours is obviously going to be halfway between 18 and 20, so there's 1900 hours. The rate of transpiration decreases. Check that it matches what it says. Yes, it does, decrease. Calculate the average rate of decrease per hour in the rate of transpiration over this time. Now, tricky stuff here. Whenever you see a question asking you for the rate, it's always something divided by time. A rate is always something divided by time. Presumably they want the decrease in transpiration, so we're going to put the rate of transpiration, okay, divided by time. They want per hour, so the time we need at the bottom needs to be in hours, and the transpiration is going to be in arbitrary units. Okay, that's the equation that we need. Amount of transpiration and by time. Notice again it's decrease per hour. So first thing we need to work out is what the decrease actually is. Okay, what's the rate at 4 o'clock? If I were you, I would use a ruler, to be honest with you, but I don't have one with me. At 4 o'clock the rate was there. Now somewhere between 8 and 9. Where? Exactly between 8 and 9. Each small square worth 0.2, 8.2, 8.4, 8.6. Okay, and at 9 o'clock, at 7 o'clock, where did we end up? Don't be afraid to draw on the graphs, it's very helpful. 0.2. Okay, so the total decrease in transpiration was 8.6 subtract 0.2, and the time in hours, well, 4 o'clock, 5 o'clock, 6 o'clock, 7 o'clock, that's 4 hours. That's the equation that you need. 8.6 subtract 0.2, divide it by 4, you end up with 2.1. That doesn't sound right to me, because I've done my maths wrong, haven't I? 4 o'clock to 7 o'clock is not 4 hours at all, is it? 5 o'clock, 6 o'clock, 7 o'clock, it's 3 hours. Very good, Miss Clear. Right, redo it. Absolutely fine. 8.6, take away 0.2, divide by 3, gives you 2.8. That's better. 2.8 arbitrary units per hour. Please don't make silly mistakes like I do, or if you do, make sure you check your work properly. Okay, between 4 and 7 o'clock is 3 hours. Divided by 3. Suggest one explanation for the decrease in the rate of transpiration between 4 and 7 hours. So we need a factor that affects transpiration that changes between 4 o'clock and 7 o'clock in the evening. Okay, think of the factors that affect transpiration. It needs to be something that decreases transpiration, that changes between 4 o'clock and 7 o'clock in the evening. Things that affect transpiration. Wind. Will it have gotten less windy or more windy? Transpiration needs to decrease, so therefore it needs to have gotten less windy. By the way, it's 2 marks, so just saying the wind decreases isn't enough. We need to explain it. If you said wind decreases, you need to say therefore less steep concentration gradient, or more shallow concentration gradient. What obvious thing changes from 4 till 7 o'clock in the evening? It gets darker. Light decreases. Let's say what happens. The stomata close when the light decreases. Interesting fact, that one. You might not be aware of that one. At temperature, would the temperature increase or decrease? In order for transpiration to decrease, the temperature would need to decrease as well. Okay, or it gets cooler, temperature decreases. Explain why that will affect the change in transpiration. Therefore, diffusion or rate of diffusion and evaporation decreases. And there's one final factor which affects transpiration. What is it? Humidity, of course. Will the humidity increase or decrease? If the transpiration has decreased, the humidity will have increased. Why will that have decreased the rate of transpiration? Because there will be, again, a less steep concentration gradient. If it's more humid, the concentration is less steep. Oh, by the way, for either of these, if you just said therefore slower diffusion, that also gets you the mark. Okay, worth knowing. Right, and there we are. We've made it to the end. Well done, ladies and gents. I know that was a long one. I hope you did well.